Have you ever wondered about the mysteries that lurk in the deep corners of our universe? Could there be more than what meets the eye? Today, we dive into the intriguing world of dark matter. In the grand tapestry of existence, there's a silent, invisible player that could be orchestrating cosmic events from behind the scenes. This elusive entity is what scientists call dark matter. Now, the term dark here doesn't refer to any color or shade. Instead, it's an acknowledgement of our ignorance about it. It's dark because it doesn't interact with light or any other form of electromagnetic radiation, making it invisible and thus dark to our current understanding. Imagine the universe as a cosmic ballet with galaxies as the dancers. The movements of these galaxies suggest a hidden choreographer, directing them with unseen forces. That's where dark matter comes into play. It's the unseen hand, the invisible puppeteer that might be driving the cosmic dance. But here's the catch. We've never directly observed dark matter. Its existence is inferred from the gravitational effect it appears to have on visible matter. This unseen force accounts for approximately 85% of the total mass of the universe. Yes, you heard that right. The stars, planets, galaxies, everything we can see make up just a small fraction of the universe. The rest is this mysterious dark matter, yet its existence is a matter of hot debate. Some scientists argue that dark matter is a misconception, a phantom born out of our incomplete understanding of gravity. They propose modifications to the laws of gravity that could explain the seemingly strange movements of galaxies without the need for dark matter. On the other side of the argument, there are those who believe that dark matter is a new kind of particle that we're yet to discover. This debate is ongoing, with each side presenting compelling arguments and evidence. So this invisible yet dominant component of the universe, dark matter, continues to baffle us. As we delve deeper into the cosmos, one can't help but wonder, what other mysteries does the universe hold in its vast dark corners? If dark matter does exist, why can't we see it, or have we been misinterpreting our observations? Dark matter, aptly named, is truly an enigma. It is believed to make up roughly 80% of the matter in the universe, yet it remains unseen and unobserved. Directly, why? The simple answer is that dark matter does not interact with light. It neither absorbs nor emits light or any other electromagnetic radiation. Hence, it remains invisible to our eyes and our instruments. Now, you might be wondering, how do we even know it's there? The answer lies in its gravitational effects. When astronomers observe galaxies, they find that the stars at the edges are moving just as fast as those nearer the center. According to the laws of physics, this should not be the case. The stars at the edges should be moving slower, but they aren't. This strange observation implies there's more matter in the galaxy than we can see, matter that's providing the extra gravity needed to speed up these stars. And that's what we call dark matter. Yet the existence of dark matter is not without controversy. Some scientists argue that we might be misunderstanding the laws of gravity on the cosmic scale. Perhaps they suggest we need a new theory of gravity to explain these observations, not an invisible form of matter. Others question our methods of observing and interpreting the universe. They argue that our indirect observations of dark matter could be influenced by biases or errors in our data. After all, we're trying to deduce the nature of the universe from our tiny vantage point within it. Despite these controversies, the majority of the scientific community currently supports the existence of dark matter. It helps us explain not just the motions of galaxies, but also the large-scale structure of the universe and the patterns we observe in the cosmic microwave background, the afterglow of the Big Bang. Hence, dark matter still remains a shadowy figure in the cosmic drama. So what does the existence or non-existence of dark matter mean for our understanding of the universe? Dark matter, if it exists, brings along significant implications for our understanding of cosmic theories. This elusive entity, which has yet to be directly observed, accounts for a whopping 27% of the universe's mass-energy balance. Quite the plot twist in our cosmic narrative, isn't it? Let's dive into the Big Bang Theory, the popular narrative of our universe's birth. This theory, formulated in the 20th century, posits that the universe started as a hot, dense point, roughly 13.8 billion years ago. Since then, it's been expanding. But here's the catch: the rate of this expansion is not consistent with the observable matter alone. Enter dark matter. with its gravitational influence, dark matter could provide the missing link in explaining this accelerated expansion. However, the existence of dark matter also brings challenges. For one, it could upend the standard model of particle physics, a framework that has held strong for over half a century. Dark matter doesn't interact with electromagnetic forces, making it invisible and undetectable by our existing tools. This property contradicts our current understanding of matter and forces us to rethink our approach to physics. Furthermore, the existence of dark matter, or lack thereof, impacts our understanding of the universe's structure. The current lambda cold dark matter model, which predicts large-scale cosmic structures, heavily relies on the presence of dark matter. If dark matter turns out to be a phantom, we'll need to go back to the drawing board. But science is all about questioning, isn't it? These challenges aren't setbacks. Instead, they are exciting opportunities for us to refine our theories, to get one step closer to the truth, even if it means disrupting long-held beliefs. Thus, the quest for dark matter could potentially rewrite our cosmic story. After all, our understanding of the universe is a tale eternally in progress, shaped by the constant ebb and flow of scientific discovery. Turning our gaze to the farthest reaches of the universe, what do strange and seemingly impossible galaxies tell us? As we venture deeper into the cosmos, we encounter galaxies that defy our understanding of physics and astronomy. These distant galaxies, located billions of light years away, exhibit peculiarities that challenge conventional wisdom. They are often larger, older, and more evolved than what our current models predict. These galaxies are like cosmic anomalies, bending the rules of our understanding and offering a new perspective on the cosmos. One such peculiarity is the existence of blue nugget galaxies. These are relatively small, young galaxies that are surprisingly blue, indicating a high rate of star formation. Their existence challenges our understanding of how quickly galaxies can evolve and form stars. Then there are the massive red and dead galaxies. They are old, quiet, and almost devoid of star-forming activity. Their size and age perplex scientists because they seem to have formed their stars too quickly and too early in the universe's history. These peculiar galaxies, among others, play a significant role in our understanding of dark matter and the universe's evolution. For instance, their gravitational effects provide indirect evidence for the existence of dark matter. Moreover, their peculiar properties are pushing us to revise our theories of galaxy formation and evolution. The distant galaxies also pose questions about the Big Bang theory. If these galaxies form their stars too quickly, does it mean the universe is older than we think? Or does it imply new physics beyond our current understanding? These are the questions that these celestial outliers prompt us to ask. In essence, these distant galaxies serve as cosmic laboratories. They allow us to test our theories, challenge our assumptions, and extend our understanding of the universe. They force us to rethink our models, to revise our theories, and to confront the limits of our knowledge. So, what do these strange and seemingly impossible galaxies tell us? They tell us that the universe is full of mysteries waiting to be unraveled. They remind us that the cosmos is a vast, complex, and ever-evolving entity that continues to challenge and inspire us. These celestial outliers, therefore, offer a unique perspective on our universe. Finally, does the existence of dark matter and peculiar galaxies challenge the notion of a God-controlled universe? This is a question that's been stirring a lot of pots lately, both in scientific and theological circles. Let's dive into this complex, multifaceted issue. The idea of God, a divine entity orchestrating the universe, has been an integral part of human belief systems across cultures and millennia. This notion, often considered in the realm of the metaphysical, is now being probed with the lens of modern scientific discoveries, such as the enigmatic dark matter and the seemingly impossible distant galaxies. On one hand, these findings might be seen as challenging the concept of a God-controlled universe. If dark matter and distant galaxies operate under laws of physics, laws that we are gradually beginning to unravel, does it not suggest a universe governed more by physical principles than by divine intervention? Moreover, the existence of strange galaxies, far from our own, might seem to diminish the significance of human life in the grand scheme of the cosmos, a notion often central to theological beliefs. On the other hand, these discoveries could also be seen as reinforcing the idea of a divine entity, The sheer complexity and vastness of the universe, from the elusive dark matter to the distant galaxies, could be seen as echoing the inscrutable and infinite nature of a divine power. Furthermore, the fact that science is yet to fully understand these cosmic phenomena might indicate that there are aspects of the universe that remain beyond the grasp of human understanding, possibly pointing towards the existence of a higher power. In the end, whether these scientific discoveries challenge or support the idea of a divinely controlled universe largely depends on one's perspective. It's a delicate dance between science and faith, and it's a dance that's likely to continue as we delve deeper into the mysteries of the cosmos. In conclusion, the universe, with its dark matter and distant galaxies, is a grand cosmic puzzle that continues to inspire intrigue and challenge our understanding.